Testing procedure. Dielectric strength test. The purpose of the dielectric strength test is to verify the electric strength of the insulation. This includes checking that the air or spacing used in the equipment is adequate. It also serves to verify that during the fabrication, the wiring and components were not displaced to the point of reducing the spacing between live and bonded parts. This is a mandatory requirement of the SPE 1000 code. What is dielectric strength? Dielectric strength is the maximum electric field strength insulation can withstand without breaking down. In the event of a failure, the electric field frees bound electrons, turning the material into a conductor and causing a flashover. Terminology. EUT. Equipment under test, also known as DUT or device under test. This is the actual product under evaluation. Routine tests. Testing to specified requirements of a production product. A dielectric strength test is a routine test. Another example would be a bond or ground continuity test. Type tests. Testing to specified requirements of one or more representative samples of equipment with the objective of verifying the adequacy of the design and manufacturing processes. Examples would include rating, temperature, or abnormal tests. The relatively high voltages used in testing the dielectric strength insulation are dangerous to life, and the utmost care should be taken while conducting these tests. The following are the minimum precautions which should be taken and, if observed, ensure a reasonable degree of safety. Safety precautions. Make sure the EUT is physically disconnected from power. Make all connections between the dielectric strength tester and EUT while the tester is unplugged. Wear all necessary PPE including safety glasses, CSA approved safety boots, and Class 1 safety gloves. Observe other safety measures based on the facility where the tests are to be conducted. Identify authorized personnel in the area and alert them to the potential dangers during the test. Only trained and authorized personnel should be permitted in the test areas. Ensure that the test equipment and EUT are dry at room ambient and on dry isolating surface. If the use of an isolating surface is not possible, ensure no part of the surface, for example a metal cart, is energized during the test. Do not touch any metal or conductive surfaces with any part of your body, and ensure no other persons or equipment are exposed to the conductive surface during the test. During the application of the high voltage, all persons, including the test personnel, should keep well away from the apparatus or appliance being tested. Be sure to have spotters or rope off the area. Do not connect the red lead to the ground of the equipment being tested. If this happens, the ground of the equipment being tested will be energized at a high voltage, which is 2,500 volts or higher. It is imperative that you wear your Class 1 safety gloves during the test and while the dielectric strength tester is energized. Never handle the high voltage test leads when they are live without the use of Class 1 safety gloves. Make sure to stay alert at all times during the test. All measurement apparatus must be calibrated according to the manufacturer's specifications or on a predetermined schedule. 2 years is acceptable. Calibration must be by an accredited facility, and a certificate of calibration is to be maintained in the QMS. The meters on the dielectric strength tester should be viewed directly above in a straight line and not at an angle so that an accurate reading can be made. It is the inspector or evaluator's responsibility to ensure that the test apparatus is appropriately calibrated and for verifying that the measurement apparatus, including interconnecting cables, is in good working condition before performing the tests. The use of a customer's testing equipment by an ESAFE inspector or evaluator to perform a test is not recommended by SPE 1000 or allowed by ESAFE. Tools needed: high pot tester, safety glasses, dielectric footwear, rubber gloves, Barriers, additional leads. Step 1. Verify that the tester and its cables are in proper working condition. Do this by connecting the leads together and performing a test. Turn HiPot tester instrument power switch to on. The power lamp and the fault lamp will now be lit. Note, this may vary depending on the model of HiPot tester under verification. Press the reset button momentarily, the fault lamp will go out, and the red high voltage lamp will come on. Top center of front panel. Turn the voltage knob clockwise until a breakdown indication between 90 and 100 mA AC or 9 and 10 milliamps DC. This verifies that the setup works properly. If additional leads are used in the setup, they must also be verified individually or in series in the same manner. Turn the voltage knob back to 0 and switch the tester off. Disconnect test leads from each other. If the meter does not trip off, the equipment will require investigation and possibly servicing. Step 2. Determine the test voltage as per the SPE 1000 code or particular standard. Step 3. Connect the high voltage leads of the tester to the appropriate terminals of the EUT. Note that all primary terminals of the EUT are tied together for this test with the connectorized leads or with the wires directly connected to the terminals of the EUT. Step 4. Turn HiPot tester on. Select the desired voltage type, AC or DC, press the reset button, and starting at 0 volts, raise the voltage at a rate of 200 volts per second or less until the test voltage is obtained, and hold for a period of 1 minute. Step 5. Gradually reduce the test voltage to 0 volts, then turn off and disconnect the tester. The EUT main on-off switch and/or other switches, breakers, line relay contacts, or other activating devices, if provided, should be in closed position during the test. If mechanical closing of some devices is not possible, the machine can be disassembled or broken down into segments or sub-assemblies and tested individually. Components providing a DC path in parallel with the insulation to be tested, such as discharge resistors for filter capacitors and voltage limiting devices or suppressors, may need to be disconnected. Where there are capacitors across the insulation under testing, for example radio frequency filter capacitors, it is recommended that DC test voltages be used. How to perform the test? For an isolating transformer, between primary and non-current carrying metal, between secondary and non-current carrying metal, between primary and secondary. For an auto transformer, between primary and non-current carrying metal only. Motors, between all leads tied together and case or ground. Discharge capacitors if unapproved. Follow all safety procedures. Always inform your customer and ensure the area is clear of personnel. Check for surge suppressors. Caution should be taken when closing contactors. Apply test voltage to the line side of contacts. Before removing your gloves, shut off the dielectric strength tester and unplug it before disconnecting it from the EUT. Once disconnected, short the leads to the tester to remove any residual voltage on the leads. As per ESAFE's internal policy from FEAPM number 21, how to complete an inspection, restoring the EUT back to its original state after testing is the responsibility of the client or its personnel. The test is passed if there is no insulation breakdown as indicated by the tripping of the current relay on the dielectric strength tester. Insulation breakdown is considered to have occurred when the current which flows because of the application of the test voltage rapidly increases in an uncontrolled manner, and the insulation does not restrict the flow of current. Current discharge or a single momentary flashover is not regarded as an insulation breakdown.